everyone, let's talk about the ideal gas law. What is ideal gas law? The ideal gas law, also called the general gas equation, is the equation of state of a hypothetical ideal gas. It is a good approximation of the behavior of many gases under many conditions, although it has several limitations. This law, the law that the product of the pressure and the volume of 1 gram molecule of an ideal gas is equal to the product of the absolute temperature of the gas and the universal gas constant.
The term ideal gas refers to a hypothetical gas composed of molecules which follow a few rules. Ideal gas molecules do not attract or repel each other. The only interaction between ideal gas and molecules would be an elastic collision upon impact with each other, or elastic collision with the walls of the container.
Here's the second few rules of ideal gas. Ideal gas molecules themselves take up no volume. The gas takes up volume since the molecule expands into a large region of space, but the ideal gas molecules are approximated as point particles that have no volume in and of themselves.
What is the ideal gas used for? Ideal gas can be used to calculate the volume of gases consumed or produced. The ideal gas equation frequently is used to interconvert between volumes and molar amounts in chemical equations.
The ideal gas law is a simple equation demonstrating the relationship between temperature, pressure, and volume for gases. Combined, this form the ideal gas law equation is PV equals to nRT, which P stands for pressure, V for volume, N a number of moles of gas, R universal gas constant, and T the absolute temperature. 2.3 moles of helium gas are at a pressure of 1.70 atm, and the temperature is 41 degrees Celsius. What is the volume of the gas? The thing that we do is to get our variable straight. Here I'm going to be using R, which is a constant. R is right here, so what is the volume of the gas? V is going to be the value that I'm solving for now. Let's plug the other one. We have the pressure of 1.070 atm. We have the amount of gas, which is 2.3 mole, and the temperature is 41 degrees Celsius, which you already know we're going to have to end up converting to Kelvin. To get to Kelvin, we have this degrees Celsius, which is 41 degrees plus 273. So temperature will be 273 plus 41, and we have 314 Kelvin. Look at this variable up here and compare their units on R, and we want them to be the same. We have to convert 8 kPa to, so it would be the same as the units on R. So we know we're solving for V, so let's go ahead now and rearrange the equation. All we're gonna do is divide both sides by P. We're gonna cancel P up here and P down there, so we're gonna be left up with V equals to nRT over P. So we're gonna take these variables and gonna plug them in. So V equals N, 2.3 moles. So we're gonna leave R times T, 314 Kelvin, divided by P, 1.70 atm, times R, 0.0821 liters atm, divided by K moles. Now we are all of our units set up here. Moles up here, moles down there, and atm down here, atm up there, and Kelvin. I'm gonna all cancel them out. It means we're only left with liters. That makes sense because we're looking for the volume. Now it's time to put this math into the calculator. I'm going to 2.3 times 314 times 0.8 times 0.0821. All of that divided to 1.70. The answer I'm gonna get is 34.87801. How many digits do I round this to? I look up here to look for the number as the fewest significant figures, and that's 2.3. The final answer has to have two significant figures. So 34 blah 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 is gonna turn into 35. 402 significant figures. And what are my units? The units is L because everything here is cancelled. So 35 liters is the volume of the gas under these conditions.
A balloon does a lovely job of containing a gas, so we use this to demonstrate these properties of gases. So, by blowing it up, it increases the number of moles of gas in the balloon, and the volume increases. And by squeezing the balloon, it increases the pressure on the gas, and the volume decreases. And by placing the balloon in the refrigerator, decreases the temperature of the gas, the volume will decreases.